Good evening, everyone, and welcome to the Form 1 to 3 classes. In this session, we're looking at a review of some of the topics that we're sent in. My first topic I'm recapping is going to be that of standard form. Now, standard form is also known as scientific notation. So you'll either hear them say, write the following into standard form or into scientific notation. Either one of them, you know it's the same steps that you have to follow. So what does scientific or standard form include? Standard form requires us to write any number into the form of some number between 1 and 10 multiplied by 10 to some power, right? So the first number must be some number between 1 and 10. Multiplied by 10 to some power. Remember, your power is also known as your exponents or the index, plural indices. All right, so there are some steps that we must note, right? So these are the steps that we must follow. My suggestion is that you write it on flashcards, or if not flashcards, you have some folder pages with notes that you must remember, right? Especially for mathematics, you just make a list of all the different things that you have to note, and you keep reviewing it continuously. So steps for writing in standard form or scientific notation. So the first step is that we write the number between 1 and 10. To do this, we put the decimal point after the first digit that is not 0. Right? So write number between 1 and 10 by placing decimal points right? So by placing decimal points after the first non-zero digits. Right, so you write down the numbers between 1 and 10 by placing decimal points after the first non-zero digits. Next, what we'll do is we're going to check. So let's say they gave us, I'll work one while we're doing it. So let's say they gave us this number, 3,200, and they asked us to write it in standard form or scientific notation. So the first step is you are putting the the decimal point after the first non-zero digit. So your first non-zero digit here is 3. So this is where you are putting the points. Your second step is you're going to check the number of decimal places from where you put the points to where it was originally. Right? So you're going to check it from where you put the point to where it was originally. Now, if you have a whole number, right? If you have a whole number, originally the decimal point is understood to be at the end of the number. So this is where it was originally. So the direction is from where you put it, which is here, to where it was originally. So you're hopping over digits one at a time. So we're going 1, 2, 3. So we moved 3 places to the right in order to get to the end. So the next step is a condition. If we moved right, so this is a condition here. So if we moved right, it's positive. But if we move left, negative. Right? So that means we moved 3 places right, so that's positive 3. Next, we're going to rewrite the number. So our third step is to rewrite the number with new decimal place right? So the decimal point in its new place multiplied by 10 to the power of the number we got in step 2. Right? So we will write the number with the new decimal place. So the new decimal place is here. Now these 2 zeros in a decimal, we don't have to write decimal, zeros after the decimal point. So we don't have to put those in. If it was any other digit or there was another digit to the end of the 0, we write all of them. Multiplied by 10 to the power of the number of places that we moved in the beginning. Right? So we moved 3 places to the right, so that's positive 3. Let's take a look at another one. So let's say they gave us this number, right? So this is number 1. So let's say number 2. They gave us So they gave us 485.33. You follow your steps. Your first step is that you are going to put the decimal point after the first digit that is not 0. So the first digit that is not 0 will be 4. So you are putting the point here. Originally, your point was here. So you check the number of places from where you put the point to where it was originally. That's the direction we're moving. So we're starting from where you put it to where it was originally. So we're moving this way. 1, 2. You're hopping over 1 digit at a time. So we had to move 2 places to the right. Next, we rewrite the number with the new decimal point. The old one is no longer where it was originally. Times 10 to the power of the number of places we moved in step 2. So we moved 2 places right, so that means positive 2. Let's take a look at another one. So let's say they gave us 0.0000426. You're following the same set of rules, right? And that's what we have to remember. In mathematics, there are some rules that we have to remember. So your first step, write the number between 1 and 10 by placing the decimal point after the first digit that is not 0. In this number, the first digit that is not 0 is 4. So we're going to put a decimal point after it. This is where you put the points. Originally, it was here. So we're going to check the number of places starting from where you put the point and ending where it was originally. So you're moving 1, hopping over 1 digit at a time. 2, 3, 4, 5. So this time we move 5 places left. Remember, if we move left, it's a negative. So we're going to rewrite that number with the new decimal point. So the decimal point is now after the 4. The zeros in front of it become insignificant. So we don't need them. And then we multiply it by 10 to the power of negative 5. And that's it. So if they ask us to write a number into standard form or scientific notation, we write the number between 1 and 10 by placing a decimal point after the first digit that is not 0. Check the number of decimal places from where you put the point to where it was originally. Rewrite the number with the new decimal place times 10 to the power of the number we got in step 2. All right, so what if they gave us it in standard form and they asked you to write it as an ordinary number or as a normal number, right? So let's say they gave you 7.4 by 10 to the power of 2. And they asked you, write the following as ordinary numbers. Or write the following as a normal number. Right? They'll most likely use ordinary, but sometimes you might see normal. Right? So rules, simple. So to change from standard form, I'll put S form for now for short. So to change from standard form into a normal number or ordinary number, what you do is we simply move the decimal points the number of places indicated by your power. Right? So remember, there's a condition. If positive, we move to the right. If negative, we move to the left. And that's it. So for this one, we have 2. If there's no sign, we understand that it's positive. So we're going to move the decimal point 2 places right. 1, 2. Where you land, you put your point, and every hump, we fill it with a 0. So that would be 740. And that's it. Let's take a look at another. So let's say they gave us 1.276 by 10 to the negative 3. Right? So you rewrite your number and we're going to move the number of places indicated by the power of the 10. So negative 3 means 3 places to the left. So we're going 1, 2, 3. Where you land, your point goes. And every hump, we fill with a 0. Right? Normally, if you have a decimal point, we put a 0 in front of it. So as an ordinary number, this will be our answer. 2 more, I'll do. So let's say they gave us 2 by 10 to the power of 3. Remember, if it's a whole number, we understand that the decimal point is after, and you're moving the point 3 places to the right. 1, 2, 3. Where you land, you put your points. Fill each hump with a 0. So that's 2,000. Even though we didn't have to go through this because 2 times 10 to the power of 3, 10 to the power of 3 means 10 by 10 by 10, which is 1,000. 2 times 1,000 is 2,000, right? But I just wanted to follow the rules to make sure that we see same rule, same thing. One more. Let's say they gave you 5.8302 by 10 to the power of 7, right? So you rewrite your number, move your points, the number of places to the right. So that's 1, 2, 3, 4, 5, 6, 7. Where you land, you put your points. Every hump, you fill with a 0. Right? So you end up with this number. And that's it. All right, so the next topic we're recapping is that of the HCF, highest common factor. Now, the highest common factor is a number that can divide into given terms without leaving a remainder. Now, let's say they gave us 2 numbers. So let's say they gave us the numbers 12 and 15. And they asked us to find the highest common factor of these 2 numbers. Now, some people, they are able to look at the 2 numbers and they could quickly identify what is the HCF. Some people, they might have to take a little longer, right? And I mean, that's okay. Now, if it is that you have trouble identifying the HCF very quickly, what to do is you take the number and you look at all the possible ways you could multiply to get that number. So like 12, I could multiply 1 times 12 and go in ascending order. So you're starting from 1 and you're going 1, 2, 3, 4, etc. So I can multiply 1 times 12. 2, I could multiply 2 times 6. 3, I could multiply 3 times 4 and I'll get 12. Once you do it in ascending order, you'll realize the numbers are going to form a loop, right? Because it didn't make sense for us to put 4 times 3 because 3 times 4 is the same as 4 times 3. So you only do it in one direction, in ascending order, and you'll realize you'll form a loop of all the factors. So the factors of 12 will be all these numbers here. 1, 2, 3, 4, 6, and 12. Then the factors are 15. Look at all the ways you could multiply to get 15. 1 times 15. We can also multiply 3 times 5. Now there's no new combination of numbers that we could multiply. So that is going to be all of our numbers there. So we have 1, 3, 5, and 15. So the highest common factor, you look at the factors of each number and you look for the highest one that is the same. And that's going to be 3. So your HCF is 3. Let's take a look at another pair. So let's say they gave you, find the HCF of 18 and 30. So you look at all the ways you could multiply to get 80. So I could multiply 1 times 18, go up in ascending order. So 2 multiplied by anything to give me 18, yes. 2 multiplied by 9 will give me 18. How about 3? Yes. 3 times 6 will give me 18. How about 4? No. How about 5? No. But 6. So you realize it forms a loop of all the factors or all the numbers that can be divided into it. So we have 1, 2, 3, 6, 9, and 18. Then we look at 30. So we have 1 times 30. I don't think I have enough space here to do all like how I want it. But let's see. So we have 1 times 30. 2 could go into it, yes. 2 could go into it 15 times. How about 3? 3, yes. 3 can multiply by 10 to give us 30. How about 4? No, but 5 can. 5 times 6. And then you realize it forms a loop of all the numbers that can divide into it without leaving a remainder. So that will be 1, 2, 3, 5, 6, 10, 15, and 30. And then we look for the highest in common. So the highest in common would have been 3 again. No, sorry, 6. I missed the 6. Right, so the highest in common would be 6. So the HCF of 18 and 30 would be 6. So you list out all the ways you could multiply to get that number. Then you look for the highest in common, and that's your HCF. All right, so let's just recap what we just did with the highest common factor. So your first step is look at all the possible ways we can multiply to get the number. Right? So we're looking at all the possible ways we can multiply to get each number. Right? Because remember, multiplication and division, they are buddies. They go hand in hand. They are opposites to each other. So whatever numbers you multiply, you could divide it into the number. So all the numbers that could multiply to give a number can divide into the given number without leaving a remainder. They're buddies. So if it is that they're given two sets of numbers, right? Remember, it could be more than two. You could even see terms as well. Right? So let's say they gave us 18 and 24. So they asked us, find the HCF of 18 and 24. So you're going to take each number and we're going to find all the possible ways we could multiply to get. So start with 1. So 1 times 18. 2, we could multiply 2 by 9. 3, we can multiply 3 times 6. 4, we can multiply 4 by anything. Any whole number to get 18, need a 5, but 6 can. So you realize it's going to form a loop of all the ways we can multiply to get that number. So 1, 2, 3, 6, 9, and 18 are all the possible ways we can, well, all the factors that can divide into 18 without leaving a remainder. Then we look at 24. 1 times 24, go in ascending order. 2 multiplied by 12 will give us 24. 3, yes, 3 could multiply by 8 to give us 24. 4 could multiply by 6 to give us 24. So we'll realize that all of these numbers, they're going to loop. And these are a list, but this is a list of all the possible factors which can divide into 24 without leaving a remainder. So we have 1, 2, 3, 4, 6, 8, 12, and 24. These are all of your factors. So we look for the highest one in common. So you're looking at all of these are common factors. So 2 is in common, 3 is in common, 6 is in common. So the highest in common would be 6. All right, so what about the LCM? LCM and HCM, they are two different things. The HCF looked at factors or numbers which can go into the number. But the LCM, that's the lowest common multiple. Right, so the lowest common multiples. Now, a multiple, when you hear multiple, think of multiplying. Right, so multiples think multiplying, and when you're multiplying, think timetables. Right? So you think of your times table. So let's say they asked you for the LCM of let's say 15 and 35. Right. So you want to find the LCM. So we're thinking timetables. Now, if you are able to use your calculator, then we just write out the timetables for 15. Right? So we have 15 times 2. Right? So 15 times 2, that will be 30. Or just keep adding 15. Right? So just keep adding 15. Add 15 again, that's 45. Add 15 again, that's 60. Add 15 again, that's 75. Let's pause here for now. 35, you're looking at the 35 times table. So if you are able to use your calculator, you just keep adding the same number. So 35 and 35 is the same as 35 times 2, that's 70. Then 105. So you just keep adding the number. If, however, you are not allowed to use the calculator, you add them manually. Right? So you just keep adding it manually. So 75 plus 15, that's 90. So you're going until you see something in common. Right? So we realize that 105, they are in common. So for the LCM, think multiplying. And when you're multiplying, think your times tables. So whatever pair, or even if it's more than one number, you look at the timetable for each of them, and you look for the lowest in common. Let's try one more. So let's say they gave you 24 and 56 to find the LCM. What you can do is do a few of the bigger numbers first, right? Not too far. So 56, add 56, that's 112. Add 56, that's 168. Pause there for now, and then you go through 24 and see if you find any common multiple. So 24, add 24 is 48, add 24 is 72, add 24, that's 96, add 24, that's 120, and it just keep going until we get one in common, and then 168. So the lowest in common would be 168. Right? So you could always start with a bigger number do a few, and then go to the smaller number. If, however, I didn't see it up to where I got up to, I just had to go further with the bigger number.